Assalamu alaikum. Welcome to the modeling of pie girder bridge in SAP 2000. Here is some information about our bridge. Height 14 inch, width of one pie 30 inch, total width 60 inch or 5 feet. Strength of material 4000 psi. Total length 10 feet. This is the cross-sectional view of pie girder. Here we can see there are two pies. Each pie is of 2.5 feet or 30 inch, and the height of the bridge is 14 inch. Steps of modeling pie girder bridge in SAP 2000. First, defining XYZ grid line, then defining material, then defining frame section by using section designer. Draw frame section into grid line. Assigning restraint, applying load by defining path, vehicle and vehicle class. Setting up load pattern, load case and load combination. Then run analysis and checking the shear and moment value. In SAP model, we open new model, then we choose grid only. We have to define the number of grid lines and the grid spacing. For X direction, we choose 2 grid line. For Y direction, we are choosing 2 grid line, and for Z direction we are choosing 1 grid line. In X direction, the grid spacing is 10 feet, and for Y direction the grid spacing is 30 inch, and for Z direction the spacing is 14 inch. Now we have to define materials. Define material for 1000 psi, modify show material. We are choosing 4000 psi concrete as our material. SAP 2000 offers a powerful utility named Section Designer for the creation of any type of section, even including pie section. The Section Designer utility accesses through the Define Section property. Define section properties, frame section, and then we are clicking Add New Property that displays the frame sections. We are choosing Other from the listed section property. Then we click Section Designer button. Base material is the previously defined material. Then we are choosing concrete column and the reinforcement to be designed. Then we click the section designer and activated it. Here some tools for designing a section in this window. This is for basically concrete material frame section design. This is our center. First we zoom in and now we check the snap to fine grit and snap to perpendicular. Then we're choosing polygon to design the pipe. We change the unit. We have to change the unit into kip inch. Here each square is 1.5 inch. Then escape. Again polygon shape. We can modify a section by reshape tool. Our section of pie is done. Okay, then okay. Now we are going to draw this frame into the grid lines. Set view option, extrude, view and fill object and labels. Apply to all windows. Now this is the 3D version of our pie girder bridge. Now we are going to define and applying load. First define moving loads and path, vehicles and vehicle class. For this we are going to need the number of the paths. Set view option, uncheck extrude and filled object. XY plane, then define moving loads, paths. Now we are going to click add new path. Our path number 1, add, again add new path defined from frames. Path number 2, okay. Now we are going to define vehicles. Define moving load, vehicle, add vehicle, axle load 2 and fixed length and minimum distance 1. Add vehicle remains fully in path. Okay. Now we are going to choose the vehicle class. Define moving loads, vehicle class. Add new class. Add. Okay. Now we are going to define the load patterns. First we have to define moving load. Then we are going to click more, vehicle life, Then we're going to click add new load pattern, then modify breeze load. We're going to add vehicle path 1, vehicle 1 path 1, direction forward and speed 1, vehicle 1 path 2, direction backward, speed 1 is added. Now we are going to define load cases. We are going to choose moving load and modify load case type to moving load. Now we are going to add vehicle 1. Now we are going to define load combination. Add new combo, then dead load and its scale factor 1.4. Add. We're going to add moving load and its scale factor is 1.9. Okay. In XY plane, we are going to select the grid lines point and then assign joint restraint. We're going to choose hinge as support. Then again choosing grid lines and then assigns joint restraint roller as support. Now we are going to run analysis. We are going to uncheck the modal. Do not run. Now from show force and stresses, we're going to check the shear and also the moment. And now the moment. This is all about modeling of pie girder. Thank you.